welcome everyone to tonight's Citizens Climate University lesson. We are going to learn about the point of assessment from the Team O.I.L analysis. We're lucky enough to be joined by three of the leaders of Team O.I.L, and I'll get into an introduction for each of them and then pass the baton off to Liz. So Liz Fisher is the Team O.I.L co-lead. She's worked 27 years in chemicals and consumer goods manufacturing for Romanos and for Clorox. She's an engineer, environmental manager, and director of manufacturing. And thank you for being on the line, Liz. We also have our very own Texan, Larry Kremer. Larry worked for decades in research and product development for Baker Hughes in the areas of refining, power, steel making, and renewable fuels. Since retiring in 2014, he's been a mentor of startup companies at Houston Technology Center. Welcome, Larry. Thank you for being here. We also have our very own Rick Knight here tonight. Rick is a chapter leader and Illinois State Coordinator and advises Legislative Director Danny Richter on energy technology issues. Rick spent 4 decades on a wide variety of energy and environmental R&D projects at the Gas Technology Institute, where he managed projects under contract with federal and state governments, as well as private industries up to $20 million. He retired there in 2016 and is now a full-time CCL volunteer. Rick, thanks so much for being here tonight on the phone as well. Just a quick kind of review of our learning goals for tonight's webinar. After listening in, hopefully you'll all be able to understand the basics of the fossil fuel supply chain and some of its infrastructure and equipment. We also hope that participants can explain what a Lac Meter is, what weight belts and metering skids do, and why there are appropriate points at which to assess a carbon fee for our policy. And lastly, we really hope that participants have the chance to access Team O.I.L as a resource to get answers to your questions on oil, gas, and petrochemical industries, and on related point of assessment questions for CCL's policy solution. For the webinar, we're going to start with Team O.I.L's background and projects review. We're going to then jump into a review of oil and gas's supply chain, and then have a little bit of a pause for a question and answer. And then we're going to pass it over to Rick to go over the point of assessment analysis, and then have more time for questions, and then end with an open forum. So with that, I will pass it over to Liz Fisher, and we'll look forward to jumping in to finding out more about Team O.I.L. Thank you, Liz.
Okay, thank you, Brett. Okay, so Team O.I.L we're the oil and gas industry liaisons. And by the way, we don't cover coal. There's another action team, Coal Country, that's led by Jim Probst, who deals with all of the coal issues. Our main functions are to be CCL's oil and gas industry liaison. So much like the member of Congress liaisons, we're the liaisons to the oil and gas industry. And we have good relationships with Exxon, Shell, the American Petroleum Institute, the Carnegie Endowment for Peace, the American Association of Petroleum Geologists. And we've talked to some other companies like Chevron, the Koch brothers, Western States Petroleum Association. But we don't have as good a relationship with them, either because they're not receptive to our ideas, or they don't engage with NGOs and would rather we just go to their website to get the information. But, you know, we're continuing to make headway. Our other part of our mission is to be the resident experts on the oil and gas industry. So we do encourage you, if you have any questions, to get in touch with us. And hopefully we can answer your question, or, you know, if we can't, it might be that we need to do a study. So we've got a lot of experienced people, so we hope that we can answer your questions. The members of our team, we are mostly oil and gas and petrochemical industry alumni. A lot of engineers, scientists, but we also have other non-oil and gas people, teachers or economists. We even have 2 emergency room physicians. We've even got a rabbi. And we welcome guests and new members, because you don't have to have a petrochemical background to ask good questions or to make good points. So it really does help us when we have more than just our petrochemical industry folks. Our meetings are the 2nd Wednesday of the month and the 4th Wednesdays, where on the 2nd Wednesday, we have our general sort of business meeting where we get updates from the liaisons and we talk about various issues. And then on the 4th Wednesday, we'll have a guest speaker and talk about a single topic. For example, this next guest speaker that we have is going to talk about recovering the materials that go to flare. So instead of burning them, he has a way of recovering them. And there you'll see our meetings are at 8 p.m. Eastern, and we've got a call-in number where you can also join us by Uber conference. And there on the left are all the logos from the folks who are on our team. So some of our projects, main projects are developing the relationships with the oil and gas industry and tracking and communicating their positions on climate change, carbon pricing, and carbon fee and dividend. And last month, on August 17th, we had another CCU on communicating the support of the oil and gas industry for carbon fee and dividend and carbon pricing. So if you want to go back and listen to that, you'll hear a lot about our relationships with Exxon and Shell and their positions on climate change and carbon pricing. Then I think everybody's probably familiar with the REMI report, at least if you've been with CCL for any significant amount of time. And that started when Jessica Langerman and Kathy Carruthers presented a very similar report that they had done for a project in Massachusetts by REMI. And Team O.I.L thought it was such a good idea that we thought, well, could we expand this to the whole US? So Peter Fikowski, who led the group then, Lou Alstad, who's a former executive vice president of Exxon, Danny, of course, Danny Richter, and a few others got together. They raised the money. They worked with REMI to get the study done, and the rest is history. And now today you'll learn about our point of assessment determination. And we're also working on a jobs study of the effect of carbon fee and dividend on oil and gas jobs in particular. You know, if you look at the REMI study, it says 91,000 jobs will be lost in the oil and gas, or I guess it's 3,000 jobs lost in the oil and gas extraction industry and 91,000 jobs in processing or vice versa, but it's not that many jobs. However, if you look in particular regions, some of those jobs are concentrated in particular areas. So while 91 plus 3, 94,000 jobs over 20 years isn't that much, we want to look at, are there particular areas of the country or particular job classes that are especially affected? And then we're working on a strategy workshop, and our first one actually to be presented this Saturday in Louisiana on how do we engage oil and gas companies in highly concentrated areas of the country. For example, this one on Saturday will be in Louisiana. We're going to do another one in Oklahoma. And in those places, they have not only the big oil refineries, but they also have some smaller companies that are especially concerned about any action on climate change. So while the big integrated oil and gas companies like Exxon, BP, Total, Shell, they support carbon pricing and moving forward to address climate change. But some of these smaller companies are a little more reluctant. And what we need to do is how can we reassure them that this is the right thing to do and that it's not going to be as bad as they're probably imagining, especially because this is all being integrated over 20 years. So that's what we're working on. I think then I'll now turn it over to Larry.
Okay, I'm going to talk a little bit about the different segments of the oil and gas industry. And it starts off with upstream. The industry divides itself into upstream, midstream, and downstream. So upstream involves exploration, where they decide where they're going to drill a well, where they think it looks promising. They get all the permits that they need, hire the people, prep the land or offshore, build the equipment, and then it goes into a drilling phase. So drilling is drilling a hole in the ground. There's another phase called completion. Once you have a hole in the ground, you have to complete the well. And probably the most famous that everybody's probably heard of is fracking, but that's just one way to complete a well. And so there's various ways that you can complete a well. And then a lot of times it will change hands. The people that have completed the well will sell it to somebody else who will actually produce the production out of the well. So all of that is included in upstream. Midstream is getting the oil from the lease where it was produced to the end user. And for crude oil, most of that is going to go to refining. Eventually, some of it will go to petrochemical, as we'll see, and product distribution. Gas has its own distribution system, but downstream is the people that are actually buying the product and turning it into something that people will buy, like jet fuel, gasoline, and lots of other things that we'll see in a minute. Next slide. There's different mindset in the different parts of the industry. So production is upstream, and obviously what they want to do is try to minimize their cost of development and minimize their cost of production. They want to try to minimize their cost, and they don't get paid unless crude flows. So they're very interested in maintaining crude flow. Transportation is more like a utility. Their job is to get the oil from the production site to the refinery who's going to do something with the oil. So they have a philosophy, they tend to be very conservative. What goes in must come out. They try to minimize losses and downtime, and they try to minimize shipping costs. And they just have a flat rate tariff for shipments that they make. And then the end users, refineries or petrochemical plants, or we'll see a slightly different group for gas, but they are interested in safe operation. They need a consistent crude slate because they have very finely tuned equipment that works on certain crudes. So they need to make sure that what they get is uniform from day to day. And they also want to make sure that they get what they're paying for. There's actually many different, above this is traders on the previous slide. And crude oil is bought and sold many times from when it is produced to when it is purchased by the refinery and processed. So natural gas has a similar sort of production. In the upper left-hand corner, you see production wells. So this would be upstream. It goes into gathering lines, and then it goes into a processing plant. And in gas, the processing plant is considered midstream. So everything past the gathering lines is midstream. And the processing plant purpose is to take wellhead gas, the gas that comes out of the ground, and turn it into something that you could transmit in a pipeline. So they have to remove all the contaminants. Probably the largest percentage contaminant is CO2, which they take out and vent to the atmosphere. Some of the other contaminants are nitrogen gas, mercury, hydrogen sulfide. There's lots of other things. And then they also skim off what are called NGLs, natural gas liquids. So that they need to get the methane to about 98%. They need to have 2% or less of CO2 in the natural gas that comes into the pipeline. And that can either go to an LNG plant, or it can be stored in underground storage facilities, or most of it goes into through the city gate, and then it goes to households, which we're familiar with, commercial people like restaurants and malls, and large volume users like various industrial enterprises. And this slide I took from the American Gas Association. So this is their concept of upstream, midstream, and downstream. In crude oil, I'm a member of Crude Oil Quality Group, which is a organization that involves producers, transporters, and refineries, and they're all interested in the quality of crude and what happens to the crude when it's transported from production. And you have an offshore platform and an onshore drilling rig here. And then there's different ways that it can get from the well to the refinery. There's rail cars, which is becoming more and more common. There's trucks. All these lines are pipelines. You can go in barges and in tankers, but eventually it all ends up in tankage in refineries. So this is when it goes into the refinery tankage is when it reaches the downstream. Most of the diagram is midstream, the transportation of the fuel, and then these two pumps are upstream. So those are the various aspects of the supply chain for crude oil in the system. Let me go into a little bit more detail on the next slide. In a typical lease, there'll be multiple wells, and the fluid from these wells will go into a series of surface equipment, and they're called separators. This is sort of a simplified diagram, but you'll notice one thing, there's water coming out of the bottom of these vessels. a lot of crude oil contains water. As a matter of fact, most crude oil contains water. And some of the production from these wells is over 90% water. And when we say water, it's actually brine, and it can be saltier than seawater. And it has to be disposed of properly. You can't dump it in rivers or the ocean. You have to dispose of it, typically in disposal wells. There's also gas associated with the oil production. And the gas, and Rick will mention this a little bit later on, but the gas can either be flared or some of it leaks. Some of it is used to run equipment and is vented to the atmosphere. And if they happen to have a pipeline nearby, then they can put it to a gas pipeline where they can sell it. But a lot of the gas is just burned or vented to the atmosphere because they don't have any way to take it off of the lease. The oil is cleaned up, and it has to get to be less than 2% water before it can be sold. And so they keep taking water out until they get it down to 2%. And then in the bottom right-hand corner, it says to oil treatment meter station and export. Well, this meter station is where they measure what the quality and volume of oil is that's produced. So that's how they know how much all these wells are producing on the lease. So the next slide shows how they measure it. This is a typical Lac Meter, lease automatic custody transfer meter. So this is how the buyers and sellers of the crude oil know how much is being produced and what the quality is, and are they getting what they're paying for, and is the producer getting paid for what he's producing. So this is how they measure the flow and quality of oil and gas. It's also how the lease owner gets paid, the person that owns the land, the mineral rights, and the surface rights. Typically, there's more than one producer. There's usually a consortium of people that get paid royalties based on what percentage they have in the production. And the government also uses this as a source of data to figure out how much oil is produced. Both the state governments that then send it to the EIA, the Energy Information Agency, where statistics are kept on production of oil in the United States. So this is how royalties are calculated. This is how everybody gets paid. And they very much want to have as accurate number as possible when it goes through this Lac meter. So one thing I wanted to mention is that not all oil is combusted. We think that this is a barrel of oil, and a barrel of oil is 42 gallons. So that's why it doesn't add up to 100. But the largest fraction is going to be gasoline, which is the green band at the bottom. And then the next band is diesel. There's an other, which is blue, and then there's jet fuel. The other is stuff like asphalt and wax. The asphalt, of course, goes on roads, and it doesn't get combusted. A lot of the wax goes into candles, so it does get combusted. Then there's some other things like LPG, and at the top there is feedstock, and this feedstock is a raw material that goes into the petrochemical industry. So there's a myriad of chemicals that are made from petroleum to make all kinds of things in our economy. And the picture on the left, there's over 6,000 products that are refined from natural gas and crude oil. And this just gives you an idea of some of the things in your life that from siding to parts of your car, to your rug, to your clothes, to your toys, a lot of things that you come in contact with actually came from crude oil. And it's not combusted. Some people have been looking at alternative feedstocks. And one of the things I'm going to mention, there's ethanol and biodiesel that everybody's familiar with. Maybe one of the things you may not be familiar with is that the number 3 producer of ethanol in the United States is Valero. They own 11 ethanol plants. And the number 5 producer of ethanol in the United States are the Koch brothers. So there's a wide variety of people producing ethanol. These are sort of advanced fuels in this diagram. The first one, ConocoPhillips ran a trial in the panhandle of Texas at one of their refineries where they took waste from a slaughterhouse and converted it into fuels. And I talked to several of the engineers on the project. When the price of oil was above $100 a barrel, it was very economic. But the price of oil dropped to $40 or $50 a barrel a couple of years ago, and it stayed down there, and this process is no longer economical. In the lower left corner is Exxon algae research. You may have seen a bunch of ads that Exxon runs on TV about how they're into algae. Well, there's lots of different companies working on algae, but everybody in the industry agrees that Exxon's easily spent well over $500 million trying to develop algae as an alternative source for fuel. In the lower right-hand corner is Fulcrum. Fulcrum has a plant in Nevada where they take MSW, which is municipal solid waste, and they convert municipal solid waste into fuel, primarily jet fuel for the San Francisco market. And I think there's another plant being built near California to also supply this market. And in the top right is the Diamond Green diesel plant, which is a 10,000 barrel a day plant making fuel from waste from a chicken plant. It's a 50-50 joint venture between Darling, which is a chicken rendering plant, and Valero, which is a refining organization. And it's next to the Valero refinery in New Orleans. This is so successful that they're going to double the capacity this year. They plan on doubling the size of the plant to 20,000 barrels a day by just building a duplicate on this plot of land next to it. So that is an idea of some of the things. So some of the takeaways, oil and gas buyers and sellers want very accurate numbers. Every time it changes hands, there's a lot of money involved, and people want to make sure that the numbers are as accurate as possible. The way that it's measured coming off of the lease is the lease automatic custody transfer meter, the Lac Meter, and it's used for custody transfer on leases. Not all oil is combusted into CO2. Some of it ends up in the petrochemical industry, some of it ends up as asphalt. So not all of but most of the oil is combusted. And then finally, refineries, a lot of refining organizations have been looking into alternatives to oil. It's all based on economics. What's economic is what they will choose.
Okay, thanks, Brett, and thanks, Larry and Liz, for your great presentation. So we had discussed how to bring industry sources on board with the carbon fee and dividend, and Team O.I.L decided to produce a document outlining the methodology for assessing the carbon fee. We produced a white paper entitled the Carbon Fee Point of Assessment Working Paper. It was a collaboration of several CCL connected volunteers with fields of expertise that could help elucidate this. It was finalized last April. We had eight authors, including myself, Ross Astoria, Bill Bray, Peter Brin, Liz Fisher, Herman Ibanez, Larry Kremer, and also Danny Richter. There were three key objectives. First, administrative efficiency and transparency, which means to minimize the administrative burden on both the fee payers and the government administrators, and also to maximize transparency for stakeholders and the public. And we achieved this by using existing equipment and field operation as much as possible. Second, optimal coverage of greenhouse gas emissions. Not necessarily maximum coverage, but optimal in the sense that we can cover as much as possible as quickly as possible while developing a roadmap for improvements down the road. And third, imports and exports, imposing the fee as far upstream as possible so that neither imported nor exported fossil fuels can bypass the carbon fee. We also wanted to make sure the policy could withstand any constitutional or trade law challenges. So the paper also briefly discusses the border adjustment for carbon-intensive goods as distinct from fossil fuels themselves. So for each type of fossil fuel, we broke down the so-called value chain into segments that would help inform the best place to assess the carbon fee. Here's the value chain for coal. Coal is delivered from the mine to a preparation or prep plant where it's dewatered, mineral matter and sulfur are reduced, and the coal is crushed and sized. But in between those, the coal is analyzed and weighed for the custody transfer or sale. The usual device for tracking the weight of coal is called a weigh feeder, which is a kind of conveyor that weighs the product continuously. So from the prep plant, The washed and sized coal is loaded onto rail cars for delivery to power plants or other customers. And finally, of course, the electricity or other products goes to consumers. So some of the coal is also exported. The pink arrows you see here represent greenhouse gas emissions, most of which is CO2 that's emitted when the coal is burned. There's a small amount of methane that can be emitted from ventilating the mine, and I'll get to that in a little bit later. So it seems that Congress is interested in the number of entities that have to pay the carbon fee. So we wanted to make sure we make that clear. In the case of coal, there are about 850 coal mines, about 500 prep plants, about 600 power plants, and other direct users of coal, and of course, 125 million residential and commercial consumers of electricity, steel, and so on. Because we want to assess the fee, that means determining how much carbon is entering the economy at the earliest point of custody transfer. It looks like the wave feeder to report out the tons of coal sold, together with the analysis of run-of-mine coal, that nails down how much carbon gets passed on. So the exit from the wave feeder, next, is in our parlance the point of assessment, and the prep plant operator then gets that information and could pay the fee depending on how much carbon they're buying from their coal suppliers. So they can pay the fee regardless of whether the coal ends up being burned for power generation, steel making, or other industrial combustion, or exported, or even if some of it is burned at the prep plant, say raising steam in a boiler. It's all captured in the coal analysis and wave feeder records. And I'll talk about methane emissions a bit later. Okay, next. Here are some shots of some of the kind of equipment that is used for measuring the coal transfer. For coal compositions, samples are grabbed at intervals and then analyzed in a lab. Then those analyses will give you the total carbon content. Next, now for natural gas, in the supply chain, many thousands of wells, as Larry pointed out, send raw gas into pipelines called flow lines and gathering lines, which then connect with bigger transmission lines that terminate at the gas processing plants. Along the way, when the gas changes hands, there will be a setup called a metering skid, where the gas is analyzed and flow is measured. Just like with coal, these data provide a definitive assay of the amount of carbon that moves downstream, and the processing plant operators will get all this data so they know exactly how much they're buying and what's in it. That information, as with the Lac meters, also goes to the lease owners. The processing plants are large facilities that remove water, sulfur gases, CO2, nitrogen, and heavy hydrocarbons that can't be allowed in the pipelines. They then compress the gas to pipeline pressure. That pipeline quality gas goes into big interstate transmission pipelines. Some of it goes to export as liquefied natural gas, or LNG. The main supply of gas, which is anywhere from 90 to 99% methane, goes to consumers, which could be power plants, your home, for heating or cooking, commercial customers, or all kinds of industrial plants. Now, there are a couple other streams which Larry mentioned, which are higher carbon liquids like propane, butane, pentane, that get removed either at the well or at the processing plant. And these natural gas liquids get sold to oil refineries or other customers. But with regard to numbers, there are something like 40,000 gas wells, but only about 500 processing plants and about 150 interstate pipelines. So there are other steps in the chain, but this is the simplified version. So where's the point of assessment? It's at where those metering skids measure the gas flow and composition before it goes to the processing plant. So as far as who pays the fee, that's something that we're going to continue working on, because it does offer some complications of making sure we don't miss any of the fossil fuel that gets burned or consumed or leaked along the way. And as far as fugitive emissions, again, I'll get into that a little bit later. Next, here's a look at the kind of equipment for natural gas assay. Unlike coal, the analysis of gas can be largely automated with computer-controlled analyzers and flow meters, similarly to the Lac meters that Larry talked about. So now there's oil. As with natural gas, the raw material goes from many thousands of wells into various kinds of pipelines. The device that measures flow and quality is what Larry talked about, the least automatic custody transfer, or Lac Meter. It works a little bit differently than the devices for gas in that it simply measures density to nail down the carbon content, which doesn't vary as much as it does for gas. But it does vary some, and that can be correlated with specific gravity. So that, together with flow measurement, provides a definitive assay of carbon that changes hands. There are a couple of other twists. Some natural gas, again, as Larry said, is produced by oil wells. That's called associated gas. And some of the natural gas liquids, the four that I mentioned, show up in this value chain. But all of these should be covered by the fee as they move downstream, as long as we assess the fee upstream as far as we can. Next, again, a few 100,000 wells, but only about 30,000 Lac meters, all of which transmit their data automatically to the owners of the assets. Lac meters may be owned by well operators or by third parties, and they're located in that second step of the chain where custody of the material changes hands. Now, in contrast to the many thousands of wells and Lac meters, there are only about 140 refineries. So there is a tension between the need to minimize the number of fee payers and to get accurate numbers as far upstream as possible. And again, that's we haven't gone into that in detail, but it's something to keep in mind. And there is a legal issue that we've discussed with Ross Astoria, our resident constitutional law professor, that you can separate the assessment, or I think the legal word is imposition of the fee, can be separated from the payment or collection of the fee. So that's something that we still need to work out. But it is a big selling point to congressional offices to keep that number of fee payment entities as low as possible. So all of these, this supply chain and imposition of the fee at the point we talked about, it keeps as many of the emissions covered as possible, except for fugitive emissions at the wellhead or the refinery or the processing plant, which I'll talk about in just a minute. Go to the next one. The point of assessment, as I said, is that in that space between the crude oil pipeline and the refinery where the Lac meters do their thing. Okay, now next slide. I promised to talk about non-CO2 emissions. Oh, I'm sorry, we got one more picture of what a couple of these Lac meters look like. Different designs, different suppliers naturally, but they remove water, they remove sediment, and they make these measurements, computer automated measurements that, as Larry said, somebody needs to go check and make sure the calibrations are correct from time to time, but for the most part, they send that data automatically to the lease owners. Okay, next. So now, what about non-CO2 emissions? Those are primarily fugitive emissions. And for those of you that are too young to remember the TV show, I put in this picture from the movie, which is also pretty old, so some of you may not even know about that one. But anyway, the main gas of concern here is methane, although nitrous oxide is also, in some cases, a fugitive. But anyway, methane, where does it come from? A wide variety of sources, including unintended leaks, but also intentional venting in some process operations, particularly during well drilling and completion. Nitrous oxide is mainly associated with coal combustion, but one interesting fact, and Larry did mention this, and it was in a recent report in the American Chemical Society newsletter, that about half of total industry methane emissions come from only 5% of the sites. So in a way that's good. It means finding and fixing those can really cut down on emissions. And most of those fugitive emissions are fixable. It just takes the incentive to get operators to do it. And this chart at the lower right shows where some of these leaks come from, or some of the emissions come from, like valves, compressors, engines, and pipelines. In many cases, they're designed to vent because that's the cheapest way to control pressure just by using the pipeline, the well gas, and they can replace those with non-venting devices, but they have to have the incentive to do so. So of course, the ideal would be to get industry-wide, consistent, accurate measurement of fugitive emissions and then apply the carbon fee with an appropriate multiplier for the particular gas's greenhouse warming potential. But the state of technology right now is just not technically feasible because of the huge number of emission points and the wide variety of ways that it's related to process operations. So there's another way though. EPA rules that were promulgated in 2016 require all gas and oil operations to report their emissions and where they come from, and coal as well. The current administration tried to delay those rules, but they were thwarted by the DC Circuit Court. So assuming that holds up, it could provide a basis to assess a carbon fee on fugitive emissions using the reported numbers. It's a pretty simple matter for coal, where those emissions are well characterized, but for oil and gas, it's more complicated, as you see. An appropriate multiplier is also needed, and that's still a matter of academic debate. So there's a lot of work to do on this aspect, but our position is that we don't want to see the carbon fee get bogged down over fugitive emissions, which are still quite a bit smaller than the huge amount of carbon dioxide that can be reduced under the main mechanism of the carbon fee. So we recommend using those EPA reports as a basis and supporting EPA requirements to reduce those emissions through an equipment replacement and maintenance protocol that's still in place. So here are the main takeaways. All fossil fuel supply chains, regardless of whether it's coal, oil, or natural gas, features devices and methods that can automatically measure and report carbon flow at an upstream point of custody transfer. That's the point where the fuel first enters the economy. Sellers and buyers of the fuel both want accurate numbers for their own economic purposes, which also meets the needs of our policy. It looks like the carbon fee assessment can be performed fairly far upstream, which means most of the greenhouse warming potential can be captured. And the fee may be paid further downstream. That still has to be worked out. And finally, not all carbon, as Larry pointed out, is combusted. A lot of it ends up as feedstocks, as asphalt. And there are ways that that money can be rebated back up the chain for non-combusted carbon. So I think that's all I have, and I'll pass it on to Brett.
Thanking all three of our speakers tonight. Thank you to Liz Fisher, to Larry Kremer, and to Rick Knight for this wonderful webinar, deeply informative, deeply helpful, and really starting to peel back the layers of what we really mean when we say as upstream as possible. If you're interested in finding out more specifically on the Team O.I.L toolkit and the paper that was written that has been referenced tonight, here is the link to that toolkit on community. You just go to the Action Teams group and then click on Team O.I.L, and much of what's presented here tonight is included and more. I know that Liz and Larry and Rick have all indicated if you have any questions to feel free to email them on any oil and gas related issue. They'll be happy to answer it or direct you to somebody who knows. And again, Team O.I.L's Buddy Drive, which is listed here, is where they archive all of their tools and meeting notes and other important documents. And that again is under community in the action teams for Team O.I.L. I'll just close by saying this. Every week we post the recording the next day. If you're interested in finding out where this is going to land, it's under the Learning Center. Here's that link. And then under the Recent Training tab. We really appreciate everyone's help in sharing this online, getting the word out to your friends and your family and social media network. And we'll close tonight by just again thanking everyone for being on the line, and have a wonderful evening, everyone.